Right. Good morning, everybody, or good afternoon or good evening from wherever you're dialing in from. Thanks for being with us today. This should prove to be quite an exciting and different type of talk to the usual Cedar Tech Talk series. The two speakers today, Ivan and Aaron, are data scientists out there in the wild, practicing their trade, and they've come here today to share with us some insights that they've gleaned so far on the road to setting up their own business. So I'll leave it over to Ivan and Aaron now, and looking forward to hear what you guys have to share with us today. Thank you.
Yeah, thanks, Adrian. Hello, everyone. We've got a full crowd today. So the thing we want to talk about today is what happens when the cost of software tends towards zero. So what are the implications of that? So myself and Aaron, we used to work together. So I did a PhD in physics, then went into data science, and that's where myself and Aaron met. And then after working together at a small consultancy, we then decided to start our own Web3 company. And obviously, starting a Web3 company, we didn't have any background in Web3. So we relied heavily on LLMs to help us write a lot of the code. I don't know, Aaron, if you want to do a quick intro of yourself.
Yeah, sure. So yeah, hey guys, my name is Aaron. I have a background in computer science and software dev, but then I recently pivoted to data science.
Cool. So today we want to talk a little bit more broadly than these talks usually discuss. So most talks will discuss how you can use LLMs in a product, so a chatbot or doing natural language processing. We're going to speak more broadly. We're going to talk about using LLMs to write code for any kind of software. So what are the opportunities and the impact of the software costs tending to zero? And then to help us think through what those implications might be, we've got two frameworks. The first is the cost and reward, and the second then is risk and verifiability. So the cost then, what we're going to say to you or try and demonstrate to you later is that the cost, or the time anyway, of developing software has dramatically reduced. And obviously if the time reduces, then the cost of development reduces as well. So I was speaking recently to another startup, and so they actually have like a proper dev team, like 10 people, and they've measured a 30% speed up of coding. And they've also replaced, they usually have 2 human reviewers to review any code that goes into production. And they've already replaced one of those 2 with an LLM. So there's already, out in the wild, real savings going on. And so the thing one of the implications we want to drive home then is if the cost of software is going down, if you imagine each of these dots as a software task or project, some of these now that previously were unprofitable have now shifted to become profitable. So then that means then we've got a lower threshold for profit. Yeah, sorry. No worries. So now we have a lower threshold for profitability. So previously, on this graph, we have the software projects, and they're ordered from large to small. So we've got Google and Meta, the very largest on the right, and they make tons of money, very profitable, but there's only a handful of them. And then as we go down this long tail of potential software that you can build, we've got enterprise SaaS. And that's roughly where the threshold for viability is at the moment. But our contention then is, as you reduce those software costs, those dev costs, you can go down this long tail of potential software that you can create down towards the niche software and the individual projects. So 2 examples we have. One is slightly tongue-in-cheek, which is you could analyze the faces on a Zoom call to measure attention. Something more serious then is you can imagine medical devices for niche conditions. That's obviously high risk, and you need to have it might be cost prohibitive to develop software for a rare condition. And so LLMs can help bring that cost down, and so make those medical devices more viable. I'm going to do a quick demo just to show people that actually, in fact, it is much quicker. So I'll walk you through the prompt first. So I'm going to just use in one prompt. Everyone's coming up to the front now. So I'll demonstrate. I'll walk you through how I usually write a prompt. So we ask it for something very specific. We want a visualization written in React. We say it's to do something with microscopy images of blood cells. We give it some context. I always like to give it some context so that it can use its common sense, so that it has some background knowledge of what it can fill in the gaps of the prompt that I've given. But then when I'm giving it what I want in the code, I'm quite specific and detailed. So I've got the list of requirements here. So I say things like, I want controls or sliders for the number of cells, the clustering, the blur. I talk about how I want it to look, things like this. So I'm very, very specific. And so if I put that prompt then into Claude, it then gives me a response. So it gives me some text to explain what it's done. And then if we open up the code, you can see then in about 30 seconds, it writes this React code. And so then if we look at what it gives us this little piece of software. The context of this and why this is useful to me or the clients that I was talking with doesn't really matter, but it just shows you that you can write something really, really quickly in no time at all. So that's the demo I wanted to give on that. And hopefully that gives a little bit of insight into if you've never prompted or, if you're struggling with using LLMs, hopefully that's a little bit of an insight. And so what I would say to you then as well, we've all had these silly ideas of, projects that we thought, oh, wouldn't it be great if this thing existed, or I could build such and such a thing, but it's going to take me too much time, or I don't have the, the software expertise. So you might be a domain expert in something else, I don't know, archaeology or God knows what. But yeah, if you want to build something, like you can now, there's a chance that you can now go from that idea that you had into a proof of concept, and you can bring it to life in the real world. So I would urge you, if you've never written software before, I would say give it a go. So we've demoed the speed of development, and I think this is where I hand over to Aaron. So I'm going to stop sharing. Being recorded. Okay, stop share. And yeah, Aaron, it's over to you. I'm going to mute myself actually.
Yeah, can you see my screen?
Yeah, we can.
Okay, perfect. So yeah, no worries. So yeah, hey guys, I'm here to talk a bit more about exactly how we've used AI for our software dev. So before diving into that, just to give you like a bit more background into what we do. So Cash is essentially what we're trying to do is basically bring price bonds or premium bonds to a broader market using crypto. At the end of the day, all that matters is that it's a web app. It's a web app that you can use on your phone. And we have a conventional system that's built using like a typical stack. So we have React for the front end, NoSQL databases for the databases, and then a couple of Python servers. Now, obviously, being a startup, our main criteria is speed. So it's all about fast iterations, making mistakes fast, and learning from them fast, making quick pivots, and then obviously faster time to markets. And all of this was enabled only because of Claude and the speed that it brought for us. And the way that we were able to do this is using Claude as a pair programming partner. And I'll give you a bit more insight into how we've used Claude. Okay. So it's not as if we built the entire app using Claude. We used Claude with different levels of involvement during different parts of the app. So to break that down, we can look at the app from three lenses. So the first level is at the UI, where there's plenty of components in the current app that were basically built completely by Claude. Now, if you think about these UI components, these are fairly low risk components that you can easily verify. It's easy for someone to look at the output and make sure that it works the way it's supposed to be. And there's no real reason for us to actually go into the weeds of all the React code and understand exactly what's happening here. Because like I mentioned, these are low risk elements. So some of the screenshots that you see on the right are basically screenshots of the app right now. Now, let's be honest here, we know we are not going to win any design awards for any of these app layouts and designs, but at the end of the day, what matters is the speed at which we were able to make them, especially considering the fact that neither of us had any experience building UI applications, or especially with React, because React is a language that has a really steep learning curve. So at the first level, it's mainly the UI. Like I mentioned, that's where most of the involvement was, because we had some entire components that were pretty much built by Claude. I'll give you a swift demo of that in the next section. The second level in which we used Claude was for the app logic. So when I say the app logic, what I mean is the way all of the different components in the UI interact with each other, as well as what happens when you click a button and stuff like that. For example, when you click the sign in button, there's obviously a bunch of stuff that needs to happen. Authentication, some writes into the database and stuff like that, reads from the database, etc. Now, this is obviously not code that you can just let the AI run wild with. you need to understand what's happening in this code. But like I mentioned, because it is React, because there is a steep learning curve, we still did use Claude, but there was always a human in the loop to make sure that things are working the way it's supposed to be. And then we just needed to make sure that everything integrated well, and that handling edge cases, all that stuff was also managed with Claude. And then coming to the third section is where it's way more high risk, which is basically the servers and the core logic of our app. So this is obviously code that we need to have complete ownership or understanding of, because these are like super high risk Python scripts that interact with the database, and especially because it's a financial app, it's financial data. So it's super high risk. So for this section, we came up with the scripts and the servers ourselves, but then we extensively used Claude for certain tasks such as code reviews, debugging, and then testing as well. Testing is something that it's really good at. Now, obviously, documentation, code review, refactoring, these are all kind of fairly obvious low-risk use cases. One thing that I found Claude to be extremely useful for was for brainstorming the architecture. So when I say architecture, what I mean is like, okay, where should certain functions reside? Should they sit within the apps? Should they sit within the servers? As well as exactly what kind of an architecture I should use for my servers. So I came up with like different architectures, but then Claude was extremely good to like bounce ideas off, where we came up with different iterations of the architecture, and then I was able to like point out different issues, and then vice versa. So for brainstorming, it's actually an extremely good tool. Now I'll actually go to a example for a UI component. Okay, so you should be able to see my Claude chat window here.
Yeah, looks good.
So this is going to be a pretty different prompt compared to what Ivan did. So Ivan had a pretty good, well-engineered prompt that was super descriptive. I approached this from the perspective of, let's say, a complete novice who doesn't, who has no experience working with React. So all I've done is essentially give Claude like a screenshot of a component that I'm trying to build. This could be a Figma wireframe that someone else has given you. This could be something that you just sketched in PowerPoint. It doesn't really matter. But what's interesting and important here is that I asked Claude to create a React component. I asked it to mimic everything in the screenshot, matching the UI as close as possible, as well as the functionalities. And then I also just specified a price chart for Ethereum versus Euro, because Ethereum is not really mentioned anywhere in the screenshot. And obviously, in order for me to test this locally, I asked Claude to give me all the steps to set up a basic React project. So out of the gate, Claude gives me like a working chart here in which the tickers work, everything works. But then it's kind of obvious that the data is not real. It's kind of mock data, but we'll come to that in a bit. But then what's more interesting is that it gives me all of the basic steps that I need to set up the project. So I have all of this set up. It's just a couple of 5-6 steps. And then it gives me the entire code that I need to create this new server. And then I have that set up here in my IDE. And then after running that, I see that, okay, it's using mock data. It's not actually using accurate historic price data. So then I just follow it up with one more basic query saying, it looks fine so far, but then can you use any API or something to actually use historic price data instead of mock data? And then that's it. That's pretty much all. But then, yeah, Claude doesn't have the capability to run APIs or call APIs within its IDE. But basically, if you run this code locally, I will show you the output that I was able to get from Claude. Yeah, that should be there. So as you can see, the time selectors work. The prices are actually accurate. Everything is accurate. The change is accurate. Everything is fine. So this is actually interesting because the prompt that I gave it was pretty bare bones. I never even asked it to like implement the time selector. Those are all things that it assumed from the prompt. And this is like a really good example of how Claude can be used to like get up and running pretty fast. And personally, in our case, what we found extremely useful was, like I mentioned, React was a language with a really high learning curve. And then Claude really helped us learn the language really fast by building components at a really fast iterative pace. Now then, yeah, I just want to cover some like high-level overview of the impact of AI. So yeah, there's some big numbers on the screen here. So based on like some surveys done by GitHub over the past couple of years, they have numbers that state that almost 97% of US developers have used AI at least once within their work. And we're not talking about like startups or anything. These are all employees from companies that have more than 1,000 employees. So these are fairly large scale enterprises and not like SMEs or startups. Now, okay, having that level of penetration is one thing, but then how do we know that it's actually making like a positive impact? So this is actually a really interesting study that GitHub again did in partnership with a university in 2023, where they took 95 developers and gave them both, and essentially an A/B test, split them into two, and gave them the same task of creating a HTTP server in JavaScript. And then one half was allowed to use AI tools, mainly their Copilot AI assistant. And then the other half, they could use Google Stack Overflow, etc., but no AI tools. Now the completion rate is fine, 78 for the half that used AI and 70 for the other half. But what's more interesting is the actual time to completion, and this is conditioned on the completion rate. So this kind of speaks for itself. That's a 55% reduction in time to complete this task, which is huge, and there's essentially no denying that. And then, yeah, there's more studies that are linked in the appendix, and then more recent surveys that show that developers use it extensively for test case generation, to understand existing code bases, especially to learn new languages, similar to the demo that I showed. But then, like I mentioned, we're coming from a startup point of view. So it's fairly easy for us to work with AI tools because we have like a small code base, and we don't really face many of the issues that larger enterprises might have. So I just want to cover some of the common challenges that are faced by bigger companies, but we are not going to go into the details of anything here. So one of the main things, main roadblocks, is obviously integrating huge legacy code. And this is a roadblock for a huge number of companies. There are a couple of options out there. One that's kind of interesting that is worth looking at is an SDK by Microsoft called the Semantic Kernel. So it's an open source tool. It's super lightweight. It essentially acts as a middleware that sits between the prompts entered by your developer and the existing large code base. So this is super interesting because it's like I mentioned, it's open source, it's lightweight, it's something that most people can easily look at. The second thing that's kind of a huge issue in terms of implementing AI into your software dev lifecycle is basically if you have like huge code bases that are like monolithic or never designed to be used in like the modern era. Even now, a huge number of companies in the US, they still have like huge monolithic architectures that are just not AI friendly. And yeah, changing these architectures into something more modern is something that a lot of companies are doing right now. So the Watson X by IBM is a tool that's being used to convert many of the COBOL systems that are used by banking into like modern Java systems. And these tools by themselves use AI, but the outcome that they bring will also help developers use AI within these companies. The other main issue that's a roadblock for most enterprises, especially within the EU, is obviously privacy. So keeping the data in-house is obviously a complicated thing. So federated learning, I'm sure most of you are familiar with the basic concepts of like training the model in-house and then just sending the model updates or the weights over the network. So this is actually being researched within the context of LLMs. So there have been a couple of research papers that are linked in the appendix where people use federated learning, and then like you don't really need huge machines. Like moderate to medium machines can train like smaller versions of the LLM locally and then update it centrally. There's also a different architecture by NVIDIA that uses smaller precursor models to train additional injections that go into the prompt, and this way you can even get away with like much weaker machines in terms of power. But like I mentioned, we're not going to go into the details of any of this. It's just to say that there are obviously plenty of challenges that enterprises face, but there's solutions for them out there. Now, you don't have to take our word to understand the impact of this. So similar to the GitHub study, it's fairly easy for any person within the software industry to test this. You can easily just design an experiment, take something that's super low risk and easily verifiable. Maybe don't go for the code generation examples like the UI demo that I showed, go for something like maybe documentation or maybe code refactoring or test case generation. But ideally, it has to be something that's low risk and well defined. And then you can basically just test this out within your company or your enterprise within using a team of senior experienced devs. But just make sure that you have the outcomes clearly specified, as well as all the metrics for success. And then you can see whether using AI or actually gives an improvement. But it's a test worth doing, because it's right now it's no longer a matter of if, it's a matter of when. So it's definitely a test worth doing to see the impact that it can bring. I believe that's the end of that. I will hand it over back to Ivan to present the rest.
Yeah, cheers. Let me swap back to my screen. Share this, share. Okay, I know. Show full screen. No. Oh yeah, sharing. Why can't I see it then? Speaker. No. Oh no. Can I not? Share screen. Share. But why can't I minimize this? But then it's just. Can I stop share? Yeah, sorry. Ah, yeah. Okay, great stuff. I'll get rid of that then. Cool. Okay, now we can see. Okay, Grant, we're back to it. Sorry, Zoom giving me issues. Okay, yeah. Okay, back to some more high-level stuff. I know Aaron obviously is the more technical of the pair of us, so he's given the more in-depth advice. So we want to look as well at just the implications for the job market, or at least like what our jobs might end up being. So there's two really interesting data sets, one from the EU and another from the US. And they take all the jobs in an economy and they split those jobs then into their component tasks. So we've got two examples here. One is a model. So one of the tasks that they have to do is, pose for a camera, maintain a portfolio, maintain their appearance. For us, we do, we analyze data, we adapt those methods to different projects, that kind of thing. But then obviously, so we said here, okay, we can be replaced by AI, but the fashion models can't. And so I should say as well, sorry, each of those tasks then for all of those jobs in the economy, they're ranked for frequency and importance. So you can, posing for a camera, you probably do that quite frequently if you're a model, and it's probably quite important to your job. But you can also then, or in the literature, what people have done is to say, okay, how exposed are each of those tasks to an LLM? Like how easy is it to automate that task with an LLM? And so they go through, and so this is some research by a couple of people from OpenAI, and they find that people like mathematicians, software developers, that kind of thing, basically what we do as data scientists is like the most exposed job you can have in the economy now with an LLM. There is a silver lining though, that thankfully people like tax accountants and solicitors are also highly exposed. So hopefully we'll see like a democratization of those white collar services to the rest of us. Yeah, it's a little bit like when a brokerage account used to cost a lot of money to make a trade. Now it's much, much cheaper or free basically. So should we as data scientists be worried? I know I'm talking to a kind of a niche audience. So what I want to do is give an example of how our job could change. So I want to recreate this analysis from a couple of people here at Cedar. So they looked at the Airbnb prices and they looked at what are the factors that affect the property price in Dublin. So I'm going to, it's demo time, and move over to, so this is, I'll just quickly give you a look at what the paper looks like. So they have a map of the Airbnbs in Dublin. They have this force plot explaining an example where it's the room type, it's the reviews per month. Those are the things that are affecting the price. And then some scatter plots, which I'm not going to dig into. It doesn't really matter what the analysis actually is. What I want to demonstrate is that I can redo a lot of the coding work, or Claude can basically do the coding work for me as the data scientist. So I've given this prompt here again, similar to before, but I've given it the PDF of the paper. I've given it a truncated version of the data set that they use, so it has that context. I'll just walk you through the prompt just briefly so you can see what I did. So I told it I want to write it in a Jupyter notebook this time, so I give it the language that I'm using. I make sure it's going to handle the errors correctly, tell it that I want to use a random forest rather than the XGBoost that was in the paper, things like this. and then the visualizations that I want at the end. So I want some B-swarm plots, I want a map plot, so it knows exactly what I'm looking for by the end. And if I can go forward, and so what we get then is it again gives me some text so that I can read and understand what it's doing, and it writes this code in about a minute. So it processes the data, prepares the new features, trains the model, and then creates the plots. So we just copy paste this into the Jupyter notebook. And so I've literally just copy pasted that exact same code into here, run it. It takes whatever it takes, and then it plots out the B-swarm plot, so we can see, okay, it's the count of beds, bedrooms, distance to Trinity. Those are the most important features. We've got similar plots to what we had in the paper, and we also have a really nice interactive map plot where we can click into the prices of each of the properties if we want. Grand. So that's the last demo. So if I go back to slideshow. So again, that's just a demo of, okay, how quickly we can code something up using Claude. But I think actually that data scientists aren't doomed. Like we're not going to lose our jobs. I actually think the job is just going to change, because if we're not spending 5 days coding and it only takes us 5 minutes, probably what we're going to do is, because I'm piggybacking off that paper, all the hard work that went into that paper, finding the data set, understanding what it means, what are the interesting questions to ask. Those are all the things that Claude is not great at. And that's the things that we can do. We can understand what's interesting to tell people. So our job is probably going to shift to something more strategic and high level. We might also be able to take on more projects. So instead of, having no jobs, hopefully we'll have even more work to do. That's the optimistic take on it. And then, so there's a pattern here that I think, if we look back over time, on the far left of the screen, you've got a navigator here. And to plot his journey, he used to have to use logarithm tables, look them up and to figure out where he's going. Then you've got an accountant in the middle. They used to have physical spreadsheets where if they wanted to make a change, they had to rub it out and, do all the different tallies all the way through. And then we got Excel to take over from that. You make a change and it just feeds through really quickly. And then finally, you've got someone working on an IDE here, and we think that's going to shift over to working with an LLM instead. And so in each of these cases, we're shifting away from doing donkey work, like doing the boring drudge work, and we're able to then build a machine to take that over for us, and then work on the interesting problems, work on the financial projections that are important for the company. Yeah, and then the next graph I want to demonstrate. Okay, so probably a lot of people are aware already in this audience of the progress that has been made with the LLMs. So I took that first prompt that I gave to Claude for those self-fluorescents, and GPT-4, which was released last year in March, just gave me some Python code instead and said it couldn't be done. Then it was 4.0 in the middle. It almost got there. The clustering doesn't work. I'm sure with a bit of iteration, you could get it to work. But Claude here, 0.1, they get it right first time, no problem. So we've already we've stepped up the capability quite a lot. Actually, I want to add to this. So we've been using the LLMs to write code for us for the last 12 months, and we've seen this expansion in capability. So it used to be that you'd be working on a couple of lines of code, you'd paste that into GPT, you'd say, okay, this is the story, this is what I'm trying to do, what's going wrong on my code. It was very, specific problem cases. Then as it's progressed, it's gotten towards being able to write entire functions for you. And now we're at the stage where you can have multiple files with functions that are interacting with each other, and you can pass all of that information into it. And when it makes a required change on one function that impacts another function, it's able to understand that and make the appropriate changes. So it's already massively expanded its capability in what it understands. If that progresses, to the stage where it can understand, complex code bases, are we going to end up with, basically software developers just replaced entirely, synthetic CTOs, this kind of thing? It's hard to say, but who knows? Yeah, okay, so the last section of this talk then is on, so we've been, as I said, using LLMs to generate or do work for us, either code generation or text generation. And what we found is, or at least for this talk, we were able to kind of distill what we are like, kind of our thinking into this framework of high risk, low risk, and whether the thing was easy to verify or not. So basically risk is just, is there a chance of something bad happening? And verifiability is how easy is it to tell, is the output correct or wrong? So I'll just give some examples to help illustrate this framework. So the one we had earlier that Aaron gave was going from, so this is just a PowerPoint mockup. So I just made this with shapes and text boxes, and I pasted that into Claude. I told it that I wanted to be built in React, and then this is the actual UI on the right then. So it's very easy to tell, okay, that's the UI that I want. And it's also pretty low risk because no one's going to die. So it's like an ideal case for the use of LLMs. Other examples, again, Aaron mentioned this, like code refactoring. It's pretty easy. You can do parallel validation. You can say, okay, this is my old code. This is the new code that the LLM has written. Does it give the same output? Yes, great. It's low risk because you're not going to push it into production without doing those tests. So that's ideal scenario. Moving towards something that's high risk, you can still validate. So something, again, like we mentioned, with medical software, so it's high risk because somebody might actually die. But it mightn't have been feasible to build software for those niche diseases. But you can now build comprehensive tests, error handling, documentation. All of this is much easier to do. It's also quite verifiable as well. So we think actually there's a large opportunity here for this kind of thing. Then the next thing, so we used actually LLMs quite a lot for text generation. So for our social media content, blogs, that type of thing. For us, it's okay because, you know, we've got a small team and it's basically it's one person handling the text. But in a larger organization, you know, there's no objective criteria for deciding, okay, is this good text? Is this following exactly the style and the tone of what we want for our blog posts? So it's pretty tricky to measure or to evaluate the output then in this case. You can do stuff with engagement metrics and A/B tests, that kind of thing. But again, that feedback is going to be quite noisy, delayed. You know, it's not as simple as, you know, does my code run exactly the way I expect it to? Another example, actually, I think, which is worth mentioning is if you're summarizing documents, you have to then, so you might just say, okay, I want my summaries to both be concise and complete. Makes sense. But how do you quantify both concision and completeness? Like someone has to turn that into a number, and however you're quantifying that, that's a design choice. Like what are the assumptions you're making? What are the simplifications you're making? And that design choice is going to affect then what you output later on. And so whoever is making that decision for you is basically deciding what your outputs are going to be later down the road. So I would just be super careful around the evaluation of text. The final example here is actually one that affected us. So for anything, again, around healthcare is obviously high risk. And if it's text, it's hard to evaluate. But actually, some of the code can be hard to evaluate as well. So we had smart contracts that were handling funds, or at least that was the idea. We had built these smart contracts that would take in assets, divvy them up, and, you know, do all the logic. And we could be sure that the logic was correct, it was working. But what we couldn't be sure was if there were vulnerabilities, like could it be hacked? We couldn't be sure of that. And so in that case, it's actually difficult to verify. I mean, you can use it as, you know, a helper tool, but you can never be 100% sure. So really, we think in these kind of cases where it's high risk and hard to evaluate, you're always going to need some kind of human in the loop, and it's going to be very difficult to scale any solutions there because you're always going to need a human working on it. So yeah, I think that's the final example. So if you want to connect with us, anyone in the audience, you know, reach out. There's the email address. You can find us on LinkedIn. Yeah, so I'll open it up to questions if anyone has any questions.
All right, thanks, Ivan. Yeah. Thanks, Aaron. Right, I'm going to just leave that on the screen just a bit longer. I'm just going to do the convention here of stop recording before we do the Q&A. So, I'm going to stop recording.